The rise of agentic AI. Let's take a look at how autonomous AI agents are redefining work, software, and business strategy. Artificial intelligence is entering a new phase. For years, AI systems answered questions, generated text, classified images, or predicted outcomes. They reacted to prompts, they responded to inputs, but now we are moving towards something far more transformative. We are entering the era of agentic AI. Agentic AI refers to systems that do not just respond, but act. They can plan, make decisions, use tools, interact with software, adapt to feedback, and pursue goals with limited supervision. Instead of asking AI to write a paragraph or summarize a document, we can now instruct it to achieve an outcome. For example, analyze our sales pipeline, identify high-risk accounts, draft personalized outreach emails, schedule follow-ups, and update the CRM. This shift from reactive tools to autonomous agents represents one of the most important technology transitions since the rise of cloud computing. And for business and technical professionals alike, understanding this shift is no longer optional. It is strategic. In this video, we will break down what agentic AI actually is, how it works technically, where it is being used today, the tools enabling it, the risks leaders must manage, and what the future may look like over the next 5 years. Let us begin with the foundation. At its core, an AI agent is a system that can perceive its environment, reason about goals, take actions using available tools, and adapt based on results. Traditional software follows predefined rules. Traditional AI models generate outputs from inputs. But agentic systems combine reasoning models, memory, tool usage, and feedback loops into an architecture that resembles a digital worker. To understand this clearly, let us break down the architecture step by step. First, there is the reasoning engine. In most modern implementations, this is a large language model or multimodal model capable of understanding instructions and generating structured outputs. This model interprets the goal. It decomposes tasks into subtasks. It decides what actions are required. Second, there is memory. Agents require context beyond a single prompt. Short-term memory may include the current conversation or task state. Long-term memory may store prior interactions, company policies, customer history, or previous decisions. This can be implemented using vector databases, structured databases, or hybrid storage systems. Third, there are tools. Tools are external capabilities the agent can call. These include APIs, databases, web browsers, code interpreters, file systems, or enterprise software systems such as ERP and CRM platforms. Tool use transforms an AI model from a text generator into an operational system. Fourth, there is an orchestration layer. This layer manages task planning, tool selection, execution loops, retries, error handling, and guardrails. Frameworks such as LangChain, Llama Index, Semantic Kernel, and various orchestration libraries provide this coordination. Finally, there is monitoring and governance. Because agents can act autonomously, logging, auditing, and oversight mechanisms are essential. Without governance, autonomy becomes risk. When these components work together, the result is not just AI assistance, it is delegated execution. Now let us explore what makes this moment different from earlier automation waves. We have had automation for decades, robotic process automation tools, automated repetitive digital tasks, workflow engines orchestrated predefined sequences. Machine learning models predicted demand or detected fraud. But all of these systems required clear rules and structured processes. Agentic AI changes the equation because it can operate in semi-structured and unstructured environments. It can interpret messy instructions, it can generate intermediate steps, it can adapt its strategy if a tool fails, it can search for missing information. For example, imagine a procurement team needing supplier risk analysis. A traditional workflow might require predefined queries and manual review. An AI agent, however, could retrieve supplier contracts, cross-reference external financial data, analyze news reports, summarize risk indicators, and produce a briefing document. If data is missing, it could flag the issue or request clarification. This flexibility dramatically expands the scope of automation. Now let us examine real-world use cases emerging across industries. In software engineering, AI coding agents are becoming powerful collaborators. They can read large code bases, propose architectural improvements, generate unit tests, refactor legacy modules, and even create deployment scripts. When integrated with version control systems and CI pipelines, these agents move beyond code suggestion and into automated change management. However, guardrails remain essential to prevent faulty deployments. In customer service, AI agents are evolving from chatbots into resolution systems. Instead of simply answering FAQs, they can verify account details, initiate refunds within policy limits, escalate complex cases with structured summaries, and update records automatically. This reduces handling time and improves consistency. In finance, agents are being deployed for internal analysis. They can consolidate data from accounting systems, identify anomalies, draft management summaries, and prepare regulatory documentation drafts. When supervised properly, this accelerates reporting cycles. In cybersecurity, AI agents can monitor alerts, correlate signals across systems, recommend remediation steps, and in some cases, automatically isolate affected assets. However, autonomy and security must be tightly controlled due to high risk of unintended consequences. In healthcare administration, agents can manage appointment scheduling, insurance verification, medical coding suggestions, and documentation workflows. Clinical decision making still requires strict oversight, but administrative efficiency gains are significant. At this point, you might be wondering how these systems are actually implemented in practice. Let us walk through a simplified enterprise deployment example. Suppose a mid-sized retail company wants an AI agent to optimize inventory replenishment decisions. The data inputs would include historical sales data from ERP systems, current stock levels, supplier lead times, seasonal trends, and promotional calendars. These data sources are connected through APIs or data pipelines. The reasoning model receives a goal such as optimize reorder quantities for the next 4 weeks while minimizing stockouts and overstock. The agent retrieves relevant data using database connectors. It analyzes sales velocity, calculates forecast projections, and compares them with supplier constraints. It may call a forecasting library or statistical tool. It generates proposed purchase orders. Before execution, a human review checkpoint may be required. Once approved, the agent submits orders through the procurement system. Monitoring dashboards track performance metrics such as stockout rates and inventory turnover. Feedback loops allow the system to adjust its strategy over time. This example highlights something critical. Agentic AI is not a single product. It is a system integration challenge. It requires data access, secure APIs, model selection, orchestration design, and governance policies. Now, let us examine the tool ecosystem enabling this trend. On the model layer, organizations can use proprietary models through managed APIs or deploy open source models within their own infrastructure. Proprietary models often provide higher performance and faster updates. Open source models offer greater control and data privacy flexibility. On the orchestration layer, frameworks like LangChain, Llama Index, and Microsoft Semantic Kernel help manage tool calling, memory, and workflow logic. Some cloud providers offer managed agent platforms that abstract much of this complexity. For memory and retrieval, vector databases such as Pinecone, Weaviate, and open source alternatives enable semantic search across internal documents. For observability, tools such as prompt logging platforms, AI monitoring systems, and application performance management solutions are increasingly integrated to track latency, cost, and output quality. Security tools are also emerging to detect prompt injection, data leakage, and abnormal behavior. Selecting tools requires balancing scalability, cost, compliance, internal skill sets, and vendor lock-in considerations. Now let us talk about risks, because agentic AI introduces new categories of exposure. First, there is the risk of incorrect reasoning. Language models can produce plausible but inaccurate outputs. If an agent is allowed to act automatically, errors can propagate into business systems. Second, there is tool misuse. If an agent has access to sensitive APIs, poorly designed prompts or adversarial inputs could trigger unintended actions. Third, there is data privacy exposure. Agents often require broad access to internal documents. Without strict access controls, confidential data may be mishandled. Fourth, there is security risk from prompt injection attacks. Malicious content embedded in web pages or documents can manipulate an agent's behavior. Fifth, there is compliance risk. Industries such as finance and healthcare require auditable decision trails. Autonomous systems must produce traceable logs. Sixth, there is workforce disruption. As agents automate knowledge tasks, organizations must manage role redesign, upskilling, and cultural adaptation. Mitigating these risks requires layered controls. Human in the loop checkpoints remain critical for high impact actions. Role based access control must limit what tools an agent can call. Output validation layers can check for policy violations. Sandbox environments can isolate testing before production deployment. Comprehensive logging and auditing should be standard. Clear accountability frameworks must define who is responsible for automated decisions. Now let us talk about risks, because agentic AI introduces new categories of exposure. First, there is the risk of incorrect reasoning. Language models can produce plausible but inaccurate outputs. If an agent is allowed to act automatically, errors can propagate into business systems. Second, there is tool misuse. If an agent has access to sensitive APIs, poorly designed prompts or adversarial inputs could trigger unintended actions. Third, there is data privacy exposure. Agents often require broad access to internal documents. Without strict access controls, confidential data may be mishandled. Fourth, there is security risk from prompt injection attacks. Malicious content embedded in web pages or documents can manipulate an agent's behavior. Fifth, there is compliance risk. Industries such as finance and healthcare require auditable decision trails. Autonomous systems must produce traceable logs. Sixth, there is workforce disruption. As agents automate knowledge tasks, organizations must manage role redesign, upskilling, and cultural adaptation. Mitigating these risks requires layered controls. Human in the loop checkpoints remain critical for high impact actions. Role based access control must limit what tools an agent can call. Output validation layers can check for policy violations. Sandbox environments can isolate testing before production deployment. Comprehensive logging and auditing should be standard. Clear accountability frameworks must define who is responsible for automated decisions. Now let us consider the strategic implications for business leaders. Agentic AI reduces the cost of coordination. Tasks that previously required multiple teams can be handled by orchestrated systems. This compresses operational cycles. It changes cost structures. It increases experimentation speed. However, the competitive advantage will not come simply from adopting agents. It will come from integrating them deeply into workflows and aligning them with proprietary data. Companies with clean data architecture, strong API ecosystems, and disciplined governance will move faster. Companies with fragmented systems and poor data quality will struggle. This creates a new form of digital maturity gap. From a technical leadership perspective, architecture decisions made today will shape flexibility tomorrow. Modular design, secure API layers, and data standardization are becoming strategic investments. At the same time, organizations must avoid over-automation. Not every process should be autonomous. High uncertainty or high ethical impact domains require stronger human oversight. Looking ahead, we can expect several major developments. First, multi-agent systems will become more common. Instead of a single agent handling everything, specialized agents will collaborate. One may focus on research, another on financial modeling, another on compliance checks. An orchestrator coordinates their outputs. Second, improved memory systems will enable long-term contextual awareness across months or years. Third, integration with robotics and physical systems will extend agentic AI beyond digital workflows into warehouses, manufacturing, and logistics. Fourth, regulation will evolve. Governments are already developing AI governance frameworks emphasizing transparency, risk management, and accountability. Agentic systems will likely face additional scrutiny due to their autonomy. Fifth, pricing models may shift from token-based consumption toward outcome-based models, where businesses pay for tasks completed rather than compute usage. Now let us ground this future outlook with practical guidance. If you are a business leader, start with constrained pilot projects. Choose a high-volume, rule-influenced, but cognitively demanding workflow. Measure cycle time, quality, and cost impact. Invest in data readiness before scaling autonomy. If you are a technical leader, focus on architecture fundamentals. Build modular agent frameworks. Implement strong observability. Design for human override capability. Prioritize security reviews from the start. If you are an individual contributor, develop literacy in prompt design, workflow automation, and AI oversight. The most valuable professionals will not be those replaced by agents, but those who know how to direct and supervise them. We are not witnessing the replacement of humans by machines. We are witnessing the redesign of digital work. Agentic AI is best understood not as a single breakthrough, but as a convergence of language models, orchestration frameworks, cloud infrastructure, API ecosystems, and enterprise digitization. The organizations that succeed will be those that treat this as a systems transformation challenge, not just a model deployment exercise. In closing, agentic AI represents a shift from asking machines for answers to assigning them objectives. That shift carries extraordinary opportunity. It also carries responsibility. The future will belong to those who combine autonomy with accountability, innovation with governance, and speed with strategy. Thanks for watching.